Hello, hello. We are starting at Chapter 8, and Chapter 8 is all about polynomials. So you learn about what those are, and we're going to do a bunch of different things with polynomials in this chapter. So, our learning target for today in Section 8.1 is simply to classify, add, and subtract polynomials. So we're going to work on those three things. So let's start off with a couple vocabulary terms. We'll do one at a time here. A monomial. A monomial is a number, a variable, or a product of numbers and variables. So here's an example. 3x squared. It's all together as one thing. That's what makes it a monomial. All right? And you can probably guess when we get to polynomials, we're going to have more of those added together. Degree of a monomial is the sum of the exponents and its variables. So sometimes you'll have, so like that would be a second degree. Sometimes we'll have like 3x squared y cubed. That's still a monomial. They're all multiplied together. They're all stuck together. But there's two different exponents for the two different variables. So that would be a fifth degree monomial because you add up the exponents. All right, now a polynomial is a monomial or a sum of monomials. So I guess technically a monomial is a polynomial. But you could have like 3x squared plus 2x plus 12. That's a polynomial because it's multiple monomials added together. Okay, and that's what we're going to work with a lot of this chapter. The degree of the polynomial is the greatest degree of any term in the polynomial. Usually, well, to find the degree of the polynomial, you must find the degree of each of its terms. Usually, if it's written in proper form, the monomial with the biggest degree will be farthest left, but it's not always the case. So you might have to find the degree of each of the terms to find the largest one, which would be the degree of the polynomial. A binomial is a sum of two monomials, so specifically two. A trinomial would be three monomials together. So specifically, we could say a monomial, binomial, a trinomial, or anything else would be considered technically a polynomial. So part of classifying binomials or polynomials is finding the degree. So to find the degree of a monomial, we kind of just talked about it already. Add the exponents of all variable terms. So, examples here. We have 5x. The only variable is x, and that has a degree of 1. So that's where we get a degree of 1 for this one. This one we have two variables with exponents. So this one has an exponent of 3, this one has an exponent of 2. You add them together, because we find the sum, it would be a degree of 5. This one we just have the y, so it's 3 is the exponent, degree of 3, and there is none, so we're going to have a 0 degree here. And let's check to make sure we got them right. They are all correct. So that's basically how you find the degree of a monomial. Why don't you try? So what do you think is the degree of each of these monomials? So why don't you pause it, write down the degree of each of these monomials, and then I will show them to you in a second. All right, so this first one was a degree 2 because we have x to the first power and y to the first power. That makes 2 total. Next one will be 5. 4 and 1 makes 5, and there's nothing for the 11, so it's a 0 degree monomial. All right, moving on. Classifying polynomials further. A polynomial is a sum of two or more monomials. We talked about that. You can find the degree by finding the largest degree of each monomial. When you're writing in standard form, and I mentioned this as well, you have the degrees of the monomials in descending order. So the largest one is always to the left, smallest one to the right. So here's an example in standard form. Because the largest degree is 4 there, then we have 2, then 1, then 0. That's why it's in standard form. It goes in descending order. Okay? So, when we're classifying polynomials, we go by two things. We look for the degree, and we look for the number of terms. So, the degree is based on, we just talked about finding the degree of it. It has to do with the biggest monomial. It also has to do with the number of terms. So an example, this first example, we would say it would be a 0-degree monomial. It is a constant, so it's a 0-degree. We could call it a constant, but it is a monomial. So, second one, we have two terms, which would be a binomial, and it is a degree of 1. So first degree binomial, or you could say it's linear, because that will be a linear, that would make a linear equation. Third one is a second degree, highest one is 2, trinomial. Again, you could call it a quadratic trinomial. That's considered a quadratic. This one's a third degree monomial, one term, but it's a third degree, so it could be a cubic is what it would be called. Um, fourth degree trinomial for this last one. Okay, fourth degree is the highest one, and it is a trinomial. There are 3 parts. So that's basically the main parts of classifying. So here's some examples, some more examples to add to that. Um, this one, I'm going to rearrange it first of all. It's 4x squared plus 3x to put it in standard form. And this is a second degree, which would be a quadratic. And it is a binomial. The reason for that is that there's 2 terms. This one right here, if you rearrange it, this is the largest one. Now be careful with this, because 5x cubed goes in front. These two combine together to make 11x. And then we have minus 1. So if there are like terms, you should combine them together, because otherwise it'll change how you would classify it. This is now a third degree. Too many e's there. But it is a trinomial. It's not a polynomial like a four-parted polynomial, because those two, the 7x and the 4x, were actually like terms. So we combine them. All right, your turn. What I'd like you to do is to take this, right here it says, write 2x minus 3 plus 8x first in standard form. Name the number, what is the name of the polynomial by its degree and number of terms. So go ahead and do that, pause it, and then I'll show you the answer. Alright, so to rearrange it into standard form, put the 8x squared in front, that's the largest term, if you're talking about degree, plus 2x minus 3. That makes it a second degree trinomial. There's 3 parts, and the degree of the polynomial is the second degree. Alright, so that is the one part of um, our learning target was to classify polynomials, and that's how you do it, by its degree and by its number of terms. Now, the next part has to do with adding and subtracting polynomials and monomials. So you can only add or subtract monomials if the variable and its exponent are the same. In other words, these are like terms. So what we're going to really be doing here is adding or subtracting like terms. But for it to be like term, the exponent has to be the same too. So add the coefficient and copy the variable slash exponents. So here's what I'm talking about. 3x squared plus 5x squared. Sorry, they're like terms because they both have x squared, and that makes a total of 8x squared. Just combining like terms. The second one, we have 4x cubed y minus x cubed y. So there's no number, you can put a 1 in front of it. That would make a total of 3x cubed y. So it's a way of simplifying things, combining like terms, adding monomials. Go ahead and try it on your own then. I'll leave those examples up. You have 2 of them for you. What is the sum there, and what is the difference? So go ahead and pause it, and I'll reveal the answers in a sec. Alright, first one, x to the fourth is the variable term, so we have -6 of them, and 11 of them, that makes 5 of them total, 5x to the fourth. The second one, we have x squared y to the fourth, and it's 2 of them minus 7 of them, which makes a -5x squared y to the fourth. Alright, so that's adding monomials. Now let's take that and add polynomials. Not going to be a whole lot different. Not going to be a whole lot different, just a little bit more. So to add polynomials, you can group like terms horizontally, or you can or write them in column form, aligning them and add them that way. So we're going to do it two different ways. Here's our example. We have 5m squared plus 8n squared minus 7mn minus 4. That all added with 3n squared plus 12m squared minus 9mn plus 2. So method 1 would just be grouping them. All right? It's up to you how you want to do this. If you want to rewrite them and group them, essentially what you're doing is you're taking the like terms and you're just adding them together. But you're grouping them first. So 5m squared plus 3, oops, plus 12m squared. So that's where we got those right here. Then we have our 8n squared and 3n squared, which is right here. Sorry. We have your minus 7 and mn, minus 9mn. So we got that right here. And then finally, our last part would be the minus 4 and the plus 2. So that's right there. When you do that, you just add the ones that you group together. So we have 17m squared plus 11n squared plus negative 16mn plus negative 2 would be your answer. Now, this method 2 that I mentioned was arranging them in column form and then adding or subtracting. In this case, we're going to add. So if you line them up by columns, it would be lined up like this. We have them so that all the like terms are lined up. And then we do it like we're adding like a 4-digit number. Like negative 4 plus 2 is negative 2. Negative 7mn minus 9mn is negative 16mn. 8n squared plus 3n squared is 11n squared. And then 5m squared plus 12m squared is 17m squared. And we get the same result here, just adding it a different way. Totally up to you which way you want to do it. You should, if you do it correctly, get the same result either method. So, subtracting them is going to be no different. Similar example, only now we have the subtraction sign in between. So, you just got to be a little bit careful with it. When you're doing method 1, we're taking them and here's a good note. Subtraction is the same thing as adding the opposite. So essentially what we're doing is we're just distributing the subtraction sign to all the parts. So that becomes a minus 3n squared. That's where we get right here. Distribute here. Minus 12m squared. That's where that is. Minus and negative become plus. And then minus 2. Okay? And now we can take that, we can regroup them if we'd like. Add them all up, we reduce it that way. Or we could line them up. And since we already distributed that subtraction, we're just adding then. Alright? And we get the same result both ways. Oops. So adding and subtracting polynomials, not much different. It's just a way of combining like terms. So, here is an example for you. You can choose whichever method you want, but I'd like you to simplify negative 4m squared minus m plus 9 minus 4m squared plus m minus 12. So I'm going to pause it. I would like you to pause it, and then I'll show you the answer in a second. Alright, so there's my result. I changed it to addition by distributing that negative. And then you can add all the like terms. So negative 4m cubed plus negative 4m cubed. Ooh, I made a mistake. Those are not like terms. Whoops. So those are actually separate. Negative 4m cubed minus 4m squared, and then minus the 2m, because those you can combine, and then the plus 21. I didn't realize those are two separate exponents at first. My mistake. So that is a way of adding or subtracting polynomials, which is the second part of our goal. Now I'm going to leave you with this real-world application. You can choose to do it. It says a nutritionist studied the U.S. consumption of carrots and celery and of broccoli over a 6-year period. The nutritionist modeled the results in millions of pounds with the following polynomials. So carrots and celery, we have that. Broccoli, we have that. And each polynomial x equals 0 corresponds to the first year in the 6-year period. So the x has to do with the number of years. What polynomial models the total number of pounds in millions of carrots, celery, and broccoli together consumed in the United States during the 6-year period? So we're going to have to take those and combine those, add those together. So I'm going to leave that with you to work on if you'd like. But I'd like you to think back to the goal, which was classifying, adding, and subtracting polynomials, and I think we did that today. So have a great rest of your day, and we'll see you next time.